All right, so our next topic, now that we have the concept of convergence and probability, we've already seen an instance of the weak law of large numbers in the case of the normal distribution, but now what we want to do is we want to prove it in general. So let's first state it as a theorem. This is called the weak law of large numbers. So that if we have an IID sequence, mean mu, variance sigma squared, then the sample mean converges in probability to mu. So let's do the proof of this. So what we need to do to prove this is we need to show, that for all epsilon bigger than 0, so we have to show that for all epsilon bigger than 0, the limit of the probability that the sample mean deviates from mu by more than epsilon is 0. So in order to do this, let's remember Chebyshev's inequality. So this is an application of Chebyshev that we haven't seen in a little while, but remember Chebyshev's inequality, which tells us that for any random variable y with a mean mu y variance sigma y squared, and we have a constant c, then the probability that y deviates from mu by more than c is bounded by the variance over sigma over c squared. So then in this case, for x bar n, we have that the expectation of x bar n is n inverse times it's the expectation of n inverse times the sum j equals 1 to n of xj, n inverse, which is, we can pull the 1 over n out. We have the expectation of a sum, and these are IID. So this is going to be n inverse times n times the expectation of x1. So the n inverse and the n cancel out, and we're left with mu. And the variance of the sum is variance n inverse times the sum. The constant comes out as a square. We have a variance of a sum of independence, so it's the sum of the variances. So it's n minus 2, n times sigma squared, so it's sigma squared divided by n. So with that in mind, what do we have for any epsilon? We have, on the one hand, the probability has to be bigger than or equal to 0. And on the other hand, the deviation of xn from its mean by more than epsilon has to be bounded by sigma squared over n times 1 over epsilon squared, sigma squared over n epsilon squared by Chebyshev. Well, now what we can do is we consider the limit as n goes to infinity. constant just converges to itself, but the sigma squared over n epsilon squared, the only thing varying here is n, so it's 1 over n as n goes to infinity. So this also converges to 0. So what happens is that this probability is being sandwiched between 0, lower bound and upper bound 0 as n goes to infinity. So this implies the conclusion proving that sample mean converges in probability to mu. So this is the first version of the weak law of large numbers. This does assume a variance. And so we're going to actually generalize this in the next video. Version 2, we're going to assume that that we have a mean, but not a variance, and we can still prove the weak law of large numbers in that case.